Hey there, folks. My name's Dan Goodman, and I want to welcome you to another rousing edition of Stormwind Studios' succinct, held online remote training sessions, or shorts, if you just want to call them that. This is the 16th and final short in the Wireless LAN Essentials series of shorts, where we focus on all things Cisco wireless LAN security. Now, some of these topics we've kind of sprinkled in throughout various shorts, and you'll see them in other areas as well. But just like every other course you find yourself in, we talk about all these cool things, and in that, the very last minute, we're like, oh yeah, we should probably secure this stuff while we're at it. So we'll identify some security features and options that are available to us via the Cisco wireless LAN deployments. This will definitely be a little bit longer than the other shorts because not only is all the bad stuff on wired networks applicable to wireless networks, but wireless networks have their own vulnerabilities that wired ones do not. We'll do a brief overview of wireless security, and then we're going to take a look at some of the options at our disposal for authentication, privacy, and integrity, and then finally the VPN options. Now, one thing I definitely want to throw out as kind of a disclaimer of sorts is there are some weak security options that we are purposely excluding from this short. Things like WEP, open authentication, web authentication, they could pop up on a certification exam. For some reason, I don't know why they would do that, but they are still out there in some way, shape, or form. We're not including them here because what sense does it make to discuss something we shouldn't use? We've already covered enough things to cover. Why should we spend time saying, hey, there's this thing out there, but you shouldn't use it. Here's the things you should use. I'm just going to choose the latter and focus on the things we should use. Many of these legacy options, for lack of a better term, are still configurable options, but once again, just because they're there doesn't mean you should use them in any way, shape, or form. So the first thing that we want to take a look at is kind of an overview of wireless security. And one thing I definitely want to throw out in the early goings is that this short could be fairly short because no matter what we do, we have to remember this fact. Our wireless signals are free floating in the air where anyone with the right equipment can intercept them. That horrifying fact aside, we've actually sprinkled in some of the security in passing during our earlier shorts. In fact, if you think back to our wireless LAN design discussion, that incorporates things like physical security because when we determine coverage and where our signal is accessible from, that's really physical security. Additionally, security needs to be a comprehensive approach. Just like we find on wired networks, we don't look at it and say, there's this and there's that. We're not going to use that. We don't rely upon a single mechanism or feature. We're trying to build in that defense in depth, just like we do in other areas. As much as possible, we need to identify the endpoints of a wireless connection, identify the end user, protect data from eavesdroppers, and protect data from tampering. So that means wireless security is going to boil down to three main things: trust, privacy, and integrity. Or to use the correct terminology, authentication and encryption. Now, with that in mind, this diagram breaks down what is considered to be pre-robust and robust security options. The earlier options were great when we were just happy to communicate sans wires, but obviously something more robust was eventually needed. These early options like WEP and open system authentication and shared key didn't require any additional hardware or really any additional overhead to implement. And if you think about it, in the early goings, wireless networking was very expensive. So anytime we could leverage what we already had, it was definitely going to be a plus. We also got to figure that wireless NICs and access points, they're kind of two sides of a different coin. They're not two sides of the same coin. They have different capabilities, they have different power levels, and all those sorts of things factored in. So what we're going to focus on here, as I've mentioned a couple of times already, are the more robust security options. Beginning with authentication, we have a couple of different options here. Now, for those of you guys who have taken other Cisco courses, you're probably familiar with 802.1x. 802.1x implements network access control at layer 2 through the implementation of the 802.1x protocol. Network connectivity is going to be permitted or denied based upon the user and or machine identity, depending upon how you've configured it. Each user device is going to be authenticated and its port will be associated to a VLAN. Unfortunately, 802.1x by itself lacks the methods for wireless clients to send their credentials. So it needs to be combined with something else in order to support wireless LANs. So that's where 802.1x with Extensible Authentication Protocol, or EAP, comes into play. IEEE added the Internet Engineering Task Force, IETF, EAP, it's a mouthful of an acronym there, to 802.1x. So we had to combine three things into one there. It is important to note that EAP does not necessarily define the authentication method, which when you look at the name of the acronym doesn't make any sense. But let me explain. It just identifies the headers used in the authentication in a format that 802.1x understands. So for lack of a better term, EAP is really the translator between the wireless headers and the wired headers, and they translate it in such a way that 802.1x can recognize, oh, this piece of information is that piece of information is this, authenticating who we need to authenticate and denying everybody else. So for lack of a better term, to extend 802.1x down to the wireless LANs via EAP, we're going to get mutual authentication for clients and the access points. We're going to get centralized management, and we're going to get policy control. So it is an extension of 802.1x, but really all it is the interpretation of the same information. So it's the same thing, just in a different format. That's what I'm trying to say here. Now, the word extensible means that there's a variety of EAP options, beginning with LEAP, or lightweight EAP. This was a Cisco proprietary authentication method where the credentials would be supplied to an authentication server. Too many authenticates in one sentence. The server and client would exchange challenges that must be encrypted in return. It is considered depreciated, but if you take a look at that previous slide with the pre-robust options, definitely better than those legacy options like web and open authentication. LEAP is considered depreciated, but definitely better than those ones. EAP, Flexible Authentication by Secure Tunneling, or EAP Fast. The credentials in this case get passed via a Protected Access Credential, or PAC, with inner and outer authentication. A shared secret would be generated by the authentication server that is used for the mutual authentication. So the client can recognize the access point can recognize the client. Basically, this is going to occur in three phases. Phase 0 is where the PAC gets generated to establish that initial tunnel. Phase 1 is where mutual authentication occurs and we establish a transport layer security, or TLS tunnel. Phase 2 is where the users are actually authenticated via that TLS tunnel. So it is a tunnel within a tunnel. The initial tunnel sets up the communication between the two devices. Once that tunnel is up, we build a second tunnel so that the credentials are sent as securely as possible, because as I mentioned, no matter what we do, those signals are free floating in the air, so we want to make them as secure as possible. Now, in order to implement EAP Fast, you do require a radius server that is capable of operating as a EAP Fast server, so make sure you evaluate that as part of your overall design. We also have Protected EAP, or PEEP, as the acronym is called. Similar inner and outer authentication to EAP Fast, but in this case, the authentication server presents digital certificates in the outer authentication. Now, the client itself doesn't require a certificate and is instead authenticated via that TLS tunnel that we just had, but we have two options there. We have MS Chat version 2, Microsoft Challenge Authentication Protocol version 2. I think I forgot an H in there. Challenge Handshake Authentication Protocol version 2, and then GTC, a generic token card. Now we can also implement one-time passwords with PEEP. Finally, we have EAP TLS, which, didn't you just say TLS? Yes, I did, but there's a difference here. This is considered the most secure option when you're factoring in the EAP discussion. With PEEP, The servers have certificates installed on them, but the clients are forced to use other methods. It's kind of the what good is, man, I cannot talk today. What is good for the goose is good for the gander. Why are the servers authenticating one way and the clients are authenticating a different way? That just presents a number of concerns. Everybody should have to meet the same standards. Now, the implementation of this requires certificates on the authentication server in every client device, but the problem that you're going to run into is not every wireless device is capable of having a digital certificate installed on them. Now, keep in mind that you can set up these security methods on a wireless LAN basis by wireless LAN basis. You know, your internal users can use EAP with TLS. Maybe your guest users use one of the lesser forms. You also need to look at the types of devices. You know, things like RFID tags or wireless scanners come to mind. Not every single one of them is capable of having a digital certificate installed on them, so they couldn't even authenticate if they wanted to. So what we've attempted to do here is kind of summarize all of these options available to us with EAP. We summarize some of the main features that you should consider in your deployment. Other options are depreciated or simply not as popular as the ones we've included here in the table. Basically, if you had to describe this in a nutshell, EAP TLS, PEEP, and EAP Fast all support what's called Cisco Centralized Key Management, or CCKM. One controller essentially will maintain a database of the clients and the keys, and that database gets provided to the other controllers and trickles down to their access points as needed. Now, in order to take advantage of CCKM, the clients do require the Cisco compatible extension support. And really the main benefit we get from that is faster roaming, because the clients can authenticate and roam much faster than any of the other options. When you take a look at EAP TLS, PEEP, and EAP Fast, they all support local controller authentication. Only EAP TLS does not support one-time passwords. EAP Fast does not require server certificates. Only EAP TLS requires client certificates. Protected access credentials are only supported with EAP Fast. Finally, since EAP TLS is the most secure option, it's also the most complicated one to deploy because, as I mentioned a second ago, every device needs to have those certificates installed on them. Now, all of these characteristics should be factored into your deployment plan because you have to factor in client support. We mentioned, and I've mentioned again, that not all clients support digital certificates. So even though EAP TLS is the most secure option, in a funny way, it may not be the best option. You have to balance security and complexity. Too much of a good thing is a bad thing, as the cliche goes. Different security methods for different client devices adds to complexity. So if you are thinking, hey, I'm going to go with EAP with TLS, you have to recognize that some client devices, they're going to get 86. They're not going to be able to connect. And that's where the trade-off comes into play. Maybe those devices you don't want on your network to begin with, or maybe you put them on a separate wireless LAN. You have to balance those two items with each other. You also have to consider your authentication server support. You may need to deploy an authentication server in order to support the EAP option you select. So factoring in authentication, the next thing we need to take a look at is privacy and integrity. Now, after covering those authentication options, how do we protect the data in open space and determine if it has been tampered with? Now, technically, wired equivalent privacy or WEP could be included in this discussion, but it is one of those options we should not be using. It's listed as a configurable option, but take away anything from what I'm about to say here. Don't use it. Don't use WEP in any way, shape, or form. Keep that in mind here momentarily. Temporal Key Integrity Protocol, or TKIP, is basically recognizing the earlier attempts at encryption. In the early goings, early attempts at encryption suffered from predictable patterns, which really defeats the purpose. If you take the most simplistic encryption and say, oh, every fourth word is going to be translated into this, that's a very predictable pattern, which defeats the entire purpose of encrypting something to begin with. TKIP was able to leverage the existing equipment that could be upgraded through simple firmware upgrades. It was developed in conjunction with the IEEE 802.11i task group, as well as the Wi-Fi Alliance, to replace WEP entirely. Now, it does form the basis of what's known as Wireless Protected Access, or WPA, but technically it was a separate entity. It's kind of like when Batman joins the Justice League. You know, he's still Batman, but sometimes he's part of the Justice League and sometimes he isn't. Same kind of thing with TKIP and WPA. Now, essentially, TKIP was an interim measure that provided a solution until WPA was ready for public consumption. TKIP uses dynamically generated and unique 128-bit encryption keys, otherwise known as temporal keys, hence the name. WEP, on the other hand, use static keys. And static, when it comes to encryption, you want to think bad because it's very simple, very predictable. Now, specifically, TKIP added a couple of features that have been rolled up into the more robust options we have now. Message Integrity Check, or MIC, adds a hash value to each frame to prevent tampering. It really doesn't prevent it, but it lets us know when somebody's tampered with the data, so it is somewhat misleading in that regard. There is a timestamp that intends to prevent replay attacks that will reuse or replay previously sent frames. The sender's MAC address is included with the MIC to identify the frame source. Kind of a way, do we trust this sender or do we not trust this sender? And then there's a TKIP sequence counter, which is used once again to prevent replay attacks. The key mixing algorithm is a unique 128-bit WEP key for each frame. We also had a longer initialization vector, otherwise known as an IV. This doubled what WEP had to 48 bits to counteract brute force calculations. Now, the reason I did this when I said WEP is because TKIP still uses WEP keys for each frame. It was depreciated back in the 802.11 2012 standard. However, it is definitely better than those options that I've chosen to ignore from this particular short. Moving onward and upward to Wi-Fi protected access. As I mentioned a second ago, this was developed by the Wi-Fi Alliance, mirrors the IEEE standards, and it is technically a certification rather than a protocol, right? It ensures the equipment adheres to a common standard of security. So it added or combined things. It kind of took away the good, added some new, and those sorts of things. We had pre-shared key or 802.1x authentication. We could use TKIP or something called counter mode with cipher block chaining message authentication code protocol, or CCMP based AES for encryption. Man, these acronyms. And then also included the MICs that were introduced with TKIP. So circling back to that mouthful of an acronym, CCMP, technically a recursive acronym because it contains an acronym within an acronym, and we can't ever have too many acronyms. CBC MAC is the acronym for that cipher block chaining message blah 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 portion of the acronym. So when you read it, it'll be CBC MAC MP. That's how we get the CCMP. So the CBC MAC basically adds message integrity. We get the MIC as well as a frame check sequence to identify if and when tampering occurs. Now, the other acronym I threw into the discussion there was the Advanced Encryption Standard, or AES. This is a block cipher that replaced the RC4 method as well as TKIP. It uses a 128-bit key and encrypts data in 128-bit blocks. Recognize that AES, just like WPA, is a standard, not necessarily a protocol. Now, WPA offered both TKIP or CCMP because legacy devices that only support WEP, of which TKIP is kind of based upon, could still take advantage of a bigger, beefier, more robust, kind of a backwards compatible option. Now, WPA was capable of operating in one of two modes. Personal mode is where we had pre-shared keys for client authentication, very useful for smaller deployments, and enterprise mode, which basically took the 802.1x EAP-based authentication and combined it with WPA, obviously, as the name implies, intended for much larger deployments. When we get to WPA2, it kind of simplified things. It said, you know what, those legacy devices that can only use TKIP, go buy a new laptop. That's essentially what they said, because they said, you know what, we're only using CCNP with AES. That's it. If you can't support those, go find another wireless network to connect to. It also certified the interoperability with EAP-based authentication. Now, I know some of you guys are thinking, what about WPA 3? We're specifically not covering it here because, in a nutshell, that's a very fluid situation, and it's not really come to fruition yet. There's a lot of kinks to work out. Enough cliches. We're skipping it because it's not listed in the Cisco documentation as of yet. So moving on to the last topic, we wanted to discuss VPNs. VPNs are obviously present in wired networks. We seem to talk about VPN options in every course, and we've mentioned them here a few times in earlier shorts. Our goal here is essentially to connect the dots between the benefits of a VPN for our wireless LANs. The security options we've discussed in this short really focus on layer 2, and VPNs focus on layer 3. Now, technically, you could add the VPN protection at layer 3 to the layer 2 protection, or skip the layer 2 protection and only focus on the layer 3 protection provided by the VPNs. Now, I'm willing to bet that most of us recognize the benefits of the standard of defense in depth, and having more security is usually better than the alternative. So just keep in mind that if you wanted to ignore everything I just said on the previous slide and just skip over the layer 2 stuff, technically you could go this route, but I'm willing to bet most of us will add this on top of the layer 2 stuff. Now, Cisco iOS Security Socket Layer VPN provides SSL VPN remote access connectivity using only a web browser. This is intended to simplify deployment of extended access to the enterprise network, and it basically provides 3 modes of VPN access: clientless, thin client, and tunnel mode. Clientless gives secure access to private web resources as well as web content, useful for most browser-based content, which is pretty much everything nowadays. There's also the thin client mode, which extends the browser's cryptographic functionality to enable remote access to TCP-based applications like POP3, SMTP, IMAP, Telnet, Secure Shell, etc. Finally, there's tunnel mode. Tunnel mode offers extensive application support through the dynamically downloaded Cisco AnyConnect VPN client. This is a lightweight, centrally configured, easy to support client. It provides access to virtually any application you can think of. AnyConnect is actually powered by Cisco's Adaptive Security Appliance, or ASA. Cisco considers that to be the industry-leading firewall, just in case you were wondering. Now, for wireless LANs, the ASA does offer various secure mobility solution components, such as built-in modules that provide enhanced security, superior connectivity features, Cisco web security, persistent security and policy enforcement, clientless access, virtual desktop infrastructure access, Cisco host scan, mobile devices, anything you can think of. Of course, the ASA can do it, right? Now, this is deployable as an on-premise Cisco Web Security Appliance, or WSA, or a cloud-based Cisco Cloud Web Security offering. Now, for those of you guys who have been working with Cisco for a while, you're probably thinking, what about the Easy VPN? The Cisco Easy VPN is retired and no longer supported. So we've got the AnyConnect option to replace that. All right, folks, that officially wraps up our final short on wireless LAN essentials. Now, we will have other shorts covering other topics, but as far as this one is concerned, you don't have to go home, but you have to get the heck out of here. We'll see you soon. Take care.